Good morning, guys. Yeah, welcome to my quick tutorial on prime numbers using SymPy, which is a library that you could use on Python. And this from SymPy import function imports all the functions that I need to use on my worksheet. So yeah, so I'm gonna start off with a prime function. So prime, the nth number. So I'll think of, say, for example, 10, the 10th prime number. Right, so 29 is the 10th prime number in the list of primes, right? And then I'll use the sieve function as well, so list. Sorry. I'm gonna go by, say, 1 and 31. Right, so the list of primes in the range of 1 and 31, so 29 being the 10th one as well. And that sieve is essentially this, the sieve of Eratosthenes. Yeah, I'm not Greek, but bear with me. Yeah, so which essentially starts off by listing 2 as the prime, then all the multiples of 2 are eliminated, then you go to the next number 3, so forth, eliminate 6, 9, and so forth, all the multiples of a number. Then eventually you're left with prime numbers, essentially. So it's just kind of a process of elimination until you're left with prime numbers within a given range. Yeah. So this is the Sieve of Eratosthenes, a Greek philosopher, right? So I'll start off with the prime, another prime as well. So prime 12. So 37 is the 12th prime number, right? And then the random prime function uh, between, say, 1 and 2001. So it will just come up with a random number between that range. So 1361, right? And I'll do another one as well. So rand prime between 1 and 53. So 11, yeah. And then the function is prime. Obviously, that returns a true or false answer. So to whether numbers are a prime number or not. So, for example, if I say 88, that's not a prime because it has 11 as a factor, it's got 4 as a factor, and so forth. So it's definitely not a prime number, right? So then I'll do another one. It's also isprime, and it's 1361. Yeah, that's true. So that's a prime number. Yeah. And then now primorial. I'll think of a number, let's say 4. Right. So as I've said there anyway, so it's just the product of the first 4 prime numbers. And if I do the same thing, it's also primorial. Um, think of a number as well, so 10. Oh, no, sorry, let me go by 7. Yeah, so that's the product of the first 7 prime numbers, right? And then another neat function as well is prime factors. So prime so this will give us prime factors of 702, right? So 2, 13, and 3, right? But then I can further factorize the number as a product of its primes. So factor int, so 702. So that's 2 times 3 cubed times 13. So 2 times 3 cubed. So this is representing cubed, and then 13, right? So that's the product, right? And then I would also do the primepi function. So let me think of a given number. Right. So there's 4 prime numbers below 8. That's what it's saying essentially. Yeah. So the 4 numbers below 8. So that's it's 2, 3, 5, and 7. Yeah. And if I can do the same thing as well, so prime 11. Right. And then that's so 2, 3, 5, 7, and 11 itself. So there's 5 numbers. Right. So yeah, hopefully this has been helpful, guys, and hope you have a great day. Thank you very much, and thanks for watching. Cheers.